Hi everyone, welcome back to our channel. Today we will learn one of the most fundamental concepts in advanced programming. It is called algorithm. We will understand what it means, why we should bother about it, and a lot more. You don't need to be intimidated by the term algorithm because it is actually a very simple concept. All it means is a strategy. In real life, anything we do, we always come up with a strategy for performing the task. For example, every time there is an exam, you can follow your strategy of preparation throughout the year. Your strategy could be to familiarize yourself with the syllabus, list books of the chapters, make plans to study and revise, and take a few mock tests. Similarly, to finish any coding task, we always need a strategy that the code will follow to finish the task. The strategy is called algorithm. Throughout this playlist, we have written many algorithms already. For example, we did an interesting example of strategy when we wrote the codes for identifying a palindrome. If you recollect, our first draft of the strategy was a simple textual instruction like this. And then we also wrote the Python code for this. Both of them are the strategy for the given task of identifying a palindrome. So, we can call both the strategies algorithms as well. We often call an algorithm for identifying a palindrome. We have just learned what an algorithm is. We have just seen two algorithms for the same task of identifying palindromes. Now you might be wondering, does it matter how we write an algorithm? Well, the answer lies in those two examples. When we express a strategy in a programming language, we call it a code. The target audience of a code is the computers. When a target audience is a human, we can also use a human language like English to express the strategy. Such an algorithm is called a pseudocode. So, in the palindrome strategies, you could not see that the first one is a pseudocode and the second one is a code. If someone asks you to write an algorithm for identifying whether a given word is palindrome, then they expect a strategy that actually works. It means they expect a working code. But before you hand over an algorithm in actual code, it is good to write the algorithm in pseudocode first. A pseudocode becomes vital when you and others, say your friend, are not familiar with the same programming languages. Now that we understand what an algorithm is and what a pseudocode is, let's close this section by doing a simple exercise. If we give you two words in lowercase, can you write an algorithm to identify if both of them are composed of the same letters or not? Take your time and think. Don't forget to share your thoughts in the comments below. Well, let us tell you how to undertake such coding tasks. First, it is very important to consider a few samples of both types. For example, if two words are art and rat, then our algorithm must print yes, because they use the same letters A, R, and T. Similarly, if two words given are rat and cat, then our algorithm must print a no. Then our next step should be writing a pseudocode. We follow the style of a book commonly known as CLRS, but we have added a few modifications for more clarity. After writing multiple iterations for the pseudocode, when we think we have enough details, we start writing a working code for the algorithm. Now let's write the first cut of the pseudocode. This pseudocode works for the positive example of rat and art. Let us take a closer look. In line 1, W1 is rat and W2 is art. In line 2, final decision is yes. In line 4, C1 is set to the first character of rat, which is R. In line 5, C2 is set to the first character of art, which is A. In the if-else loop, the control goes to else block, and in line 9, final decision is set to no. Now the control comes to the end of the inner for loop in line 11. Since all characters of W2 are not visited yet, the control goes back to the beginning of the inner for loop at line 5. C2 is now the second character of art, which is an A. C1 is still R and it matches with C2. In line 7, final decision is set to yes. Then the control exits the inner loop and arrives at line 12. In line 13, it reaches the end of the outer loop. Since all characters of W1 are not visited yet, the control goes back to the beginning of the outer for loop at line 4. C1 is now the second character of rat, which is an A. In line 5, the control enters the inner for loop freshly, so C2 is restarted at the first character of W2, which is A. Again, final decision is set to yes in line 7, and the control exits the inner loop and arrives at line 12. Like before, the control goes to line 13 and then to the beginning of the outer for loop at line 4. C1 is now the third character of rat, which is a T. C2 restarts and sets to A. In line 9, final decision is set to no, and the control comes to line 11. The inner for loop still has the next character, so the control comes to line 5 and C2 is set to R. Again, C1 does not match C2, and in line 9, final decision is set to no. Then the control comes to line 11. From line 11, the control goes to line 5 and C2 is set to the third character T. This time C1 and C2 matches, and in line 7, final decision is set to yes. Then the control exits the inner loop and comes to line 12, and then to line 13, and then even to the beginning of the outer for loop at line 4. But all words of W1 are already visited, so the control gets out of the for loop to line 14. In the next line 15, the latest value of final decision is printed. This is yes. Even though the positive sample works here, a careful look at the negative sample of rat and cat will also print yes. But we expect a no here. Neither R nor C is present in both the words. Can you think of a way to fix this? The reason why the negative samples of rat and cat wrongly prints a yes is when C1 is R does not find any match in W2. The control does not exit the outer loop. Let's take a closer look. In line 4, the outer loop starts and sets C1 to R. In line 5, the inner loop starts and sets C2 to C. C1 and C2 do not match. So in line 9, final decision is set to no. The control comes to end of for loop at line 11. The inner loop takes the next iteration, and in line 5, C2 is set to A. Again, C1 does not match C2, final decision is set to no, and the control comes to end of for loop at line 11. The inner loop takes the next iteration and in line 5, C2 is set to T. Again, there is no match and the control comes to the line end of the inner loop at line 11. At this point, we should have made a decision to exit the outer loop and go to the print in line 15. But there is no decision block in line 12. So the control goes to line 13, the end of the outer for loop. And the next iteration of the outer loop starts at line 4. Now it is very clear that all we need is a decision block in line 12. This new code in line 12 should exit the outer loop if the final decision is no. It's time to verify our algorithm with few positive and negative samples. Both the positive and negative samples are identified by the algorithm as expected. It is always good to test more cases. So we try another pair of positive and negative cases each. But now we discover that there is a flaw in the algorithm. Can you find a sample code to show the flaw? Well, just reversing the pair catch and cat, we see the algorithm wrongly prints yes. This is because when W1 is cat and W2 is catch, W2 has all the characters of W1 plus some more additional characters. Since our algorithm baselines W1, this problem will always arise for any such cases. For example, for and fort, pot and topper, and so on. Now let us share some tips on critical thinking and reasoning. Remember that in many such situations, you always have two options. Either to fix the current approach and to think of another approach. With practice and experience, you can learn to decide which option to go for. In general, if you have tried fixing any option for a few times, it's better to put a pin on that and go for a fresh approach. In fact, we will just do that now. Before we share a new approach, can you take your time and come up with another algorithm with fresh ideas? Let us know in the comment section what are your thoughts. We close there for today and resume the next episode with an algorithm that actually works. Get your algorithm ready before we meet next time. See you soon. Ciao.